Hello ladies and gentlemen, welcome to the Astronomy Universe channel. Today we're diving into a visitor from space that set the international astronomy community abuzz. Asteroid 2024 IR4. Never before has such a modest, cosmic rock roughly the height of a 10 to 20-story building garnered this level of attention. Just type 2024 IR4 into YouTube and you'll find a flood of videos, reports, and lively analyses. Discovered less than 2 months ago, its chance of impacting Earth has steadily climbed, sparking widespread concern. In this video, we'll retrace its discovery, review the latest collision probability updates, examine its unpredictable orbit, compare it to notorious names like Apophis and Bennu, and explore what NASA and the astronomy community are doing to track and respond. Buckle up, our journey into the world of 2024 IR4 is about to begin. At the end of 2024, the Cerro Tololo Observatory in Chile detected an unusual signal from a small object passing near Earth's orbit. Within just a few hours of analysis, astronomers recognized it as a newly discovered asteroid designated 2024 IR4 following the Year of Discovery Plus Code convention. With an estimated diameter of only 40 to 90 m, IR4 doesn't belong to the ranks of giants like Apophis or Bennu, but it is still large enough to trigger a city-scale disaster on impact. As soon as its preliminary orbit was calculated, the data were shared on a global network, kickstarting the effort to compute its collision probability and coordinate close monitoring across observatories worldwide. Less than a month later, on January 27, 2025, NASA officially added IR4 to its potentially hazardous asteroids list, recording an initial impact probability of about 1.3%. When multiple observing teams provided additional position and timing measurements, that probability unexpectedly climbed to 2.3% on February 7. Such rapid fluctuation underscored the large uncertainties still affecting IR4's orbital solution, uncertainties driven by both the quantity and quality of available observations, and sent ripples of concern through the international astronomy community. Continued tracking led NASA to update IR4's impact probability to 2.6% on February 18, 2025, and most recently to 3.1%, roughly 1 in 32. This is the highest probability ever recorded for an object less than 2 months past discovery. While 3.1% may sound small, among the thousands of known near-Earth asteroids, IR4 now tops the short-term risk charts. Crucially, the upward trend has yet to level off, as IR4 is entering a region of space sparsely covered by observations amplifying the margin of error in orbital forecasts. IR4 follows a highly eccentric ellipse. It reached perihelion on November 22, 2024, plunging inward, nearly to Mars's orbit, then swung back out almost to Jupiter's orbit. Mid-cycle, it passed Earth's front door twice, first on December 25, 2024, at a distance of about 288 kilometers, 2.1 times the Earth-Moon separation. Although extremely close on a cosmic scale, this approach posed no immediate threat. Each such flyby, however, offered a vital chance to refine orbital models and update collision probabilities. Models predict IR4's next near-Earth encounter on December 17, 2028, when it will pass at roughly 8 million km comfortably safe distance. But the final showdown is forecast for December 22, 2032 at 14, 2 UTC, 21, 2 Hanoi time, with an impact probability of 132, 3.125%. This 8-year-out warning carries the highest risk ever assigned to a freshly discovered asteroid. After its December 2024 close approach, IR4 faded quickly. By mid-February 2025, 1 M-class telescopes could barely detect it. By March 4, only 4 meter telescopes could pinpoint its position accurately. And by early May, 8 meters apertures limited to a few major observatories globally were needed. The resulting paucity of observations widened orbital uncertainties and drove up the calculated impact probability. Should IR4 collide with Earth, the explosion would unleash the equivalent of 8 megatons of 10 hundreds of times the yield of the Hiroshima bomb. The blast would flatten thousands of square kilometers of urban landscape, generate shock waves that obliterate structures, cast up a dust plume to shroud the sky, and trigger long-term environmental effects. In a densely populated region, casualties could number in the hundreds of thousands. This scenario is not science fiction, but the outcome of rigorous scientific simulations. By comparison, asteroid 99,942 Apophis, about 450 m across, some 5-10 times larger than IR4 once, carried a calculated 2.7% impact chance for April 13, 2029. However, after additional optical and radar measurements, that risk was ruled out, returning Apophis to a safe status. With an orbital period of 323.7 days, Apophis passes Earth twice yearly but now poses no concern. Thanks to Goldstone radar and precise optical tracking, NASA has confirmed it cannot collide this century. Simulations show it will slip by at about 600 kilometers closer than geostationary satellites, yet still safe. The drop from serious risk to virtually zero powerfully illustrates the importance of continual observations and orbit refinements. Another heavyweight is 101,955 Bennu 490 m in diameter, studied by NASA's OSIRIS-REx mission, which returned 121.6 g of surface material. Bennu's impact probability from 2,175 2,199 stands at about 0.059%, peaking on September 24, 2,182. Putting IR4, Apophis, and Bennu on a risk scale reveals that IR4, 4090 mine, the smallest now, has the highest short-term impact probability, 3.1% in 2032, far exceeding Apophis, 0% in 2029, and Bennu, 0.059% in 2000, 175 2,199. In terms of impact energy, IR4 miles 8 mount lags behind Apophis, 6,300 mount, in Bennu, 200 mount. But in urgency, IR4 stands alone. To narrow these uncertainties, NASA's JPL, ESA, and a global network from Arecibo, under repair, and Goldstone, to large telescopes in Chile, Hawaii, and Arizona are continuously gathering radar and optical data. NOAA contributes atmospheric models to calculate solar radiation pressure. NASA's Planetary Defense Office is even planning simulated exercises for kinetic impactor or nuclear deflection missions targeting IR4. An asteroid's path is shaped not only by planetary gravitation but also by the Yarkovsky effect, thermal emission, and solar radiation pressure. These invisible forces can nudge its trajectory off earlier predictions, so regular observation campaigns every few weeks are key to tightening error margins and driving the impact probability back down towards zero. Imagine that on December 22, 2032, after 650 days of monitoring, the final data arrive showing a mere 0.05% chance of impact. That could be a moment of relief, or the last warning for a vulnerable city. In the worst case, a massive fireball would descend. In the best case, deflection efforts have reduced the risk to near zero. Either way, the enduring lesson is one of vigilance, international collaboration, and preparedness against celestial threats. Asteroid 2024 IR4 may be small, but with its unprecedented collision probability, it has become a hotspot in astronomy. Every measurement and every orbital calculation contributes to safeguarding a city, a nation, even our entire planet. Follow Astronomy Universe for the latest updates, in-depth analyses, and gripping cosmic scenarios. Don't forget to like, share, subscribe, and hit the notification bell so you never miss an important space news update.